Hi, and welcome to That Repair. Today we are going to repair a water damaged motherboard of an MSI GS63. This is one of my first attempts to publish a video, and also my English is not very good, but I think it's enough to understand what I'm doing here. Usually when water damage occurs in specific areas like in this board, in little areas, the process is straightforward. You have to find the corroded spots and replace the corroded components. When water is spilled on the board, what happens is that the contacts are oxidized and are broken. So you have to find in which areas that has happened and fix those areas and possibly replace any damaged components. The corrosion of the contacts begins when there is electricity present, and the higher the voltage, the faster the reaction. What you have to do when you spill water is remove instantly the power adapter and the battery. But if the water reaches the motherboard, then the corrosion happens in just a few seconds. So you don't have any time to remove the battery that's located usually inside the computer. So what you can do is to quickly turn the laptop upside down with the keyboard facing downwards, so the water doesn't have the chance to get into the motherboard from the keyboard, and put a towel to collect the water. So let's see now how the motherboard reacts when plugged in. I have soldered a little wire here, which is the power button, so we can turn on the motherboard with this, and we plug the DC power from the power source here, and let's check. So no consumption yet, and we try to power on the motherboard and nothing happens. So there is definitely there is some consumption, but it's not enough. Usually when the laptop turns on, there is about 1 ampere, 1.5 ampere, or maybe more. This is a donor board we'll be using to take the components required to fix the other board. It's very handy to have one, because if you don't, then it's very difficult to find the required parts online. And even if you find them, they will be delayed too much, and also you may be required to make a second order after you find that the parts you got are not enough to fix the board, and so on. This is the microscope camera now. I have already found some areas that have been affected by the water, so let's have a look. The first area is here. It seems that the user has tried to repair here something. This is the RGB controller for the keyboard. It doesn't affect the power on status of the laptop, so it is not related to that. But this area needs also to be fixed. You can see that some pins are shiny and some other are black. Those that are black are those that have been damaged more by the corrosion. So we will have to replace some of these components, and some other components will stay here and will just be resoldered, so the connection is restored. Before we start repairing those, let's look at the other areas as well. This area is responsible for the 3.3 and the 5 volt rails generation. We see here that There is also some damage done here. So probably this is why the laptop is not turning on, because the other circuit that we just saw recently was for the RGB on the keyboard. There's a high chance that the main issue is located at this area and not the other one. This is the last area spotted. There's no much going on here. You see the same effect, that one of those pads is black and the other one is shiny. That's because this is ground and this is 19 volt. So we will probably remove this, look under it and put it back, because the pins seem to be okay. And then resolder a bit this area. So this is a little bit black, so you can see I scrape it and it shines. And the same for this one and for this one. Some of these test points are used for bridging. So if it's corroded, it will not connect one side to the other one. So it has to be resoldered. And that's it. This area is not affected too much. Let's begin with this area, the easy one. And then we'll continue to the other areas as well. After cleaning this chip, one of its contacts broke, so that means that it was corroded, and this will also be replaced. Let's place the components back from the donor board. Let's remove this capacitor too. There is a plastic connector here, so we need to be careful with that. Now this is the most crucial area because this is the regulator which forms the 3.3 and 5 volt voltages for the motherboard. And if something here goes wrong, the motherboard may be trashed in a second, because from 3.3 and 5 volts, everything on the motherboard gets power, like the PCH, the chipset, the GPU, all the other regulators, the audio IC, the LCD, everything, just everything. So we need to be extra careful here. And of course, as I mentioned previously, this is why the motherboard does not turn on. So we will do the same thing here. We will replace the components that seem bad, and of course we need to remove the regulator as well, and I will replace it because this is a very important part of the motherboard. So now let's clean this and see what we've got. Many times you can find broken contacts that need to be repaired with the wire. Let's hope that this is not the case. You can see under this black thing there is copper that we can still solder on. Let's put some more flax. So the pads are okay. That's a good sign. So the pads are in very good condition. Now we'll replace the damaged parts and continue. I'll be using a brand new chip for this because I think it's a very important circuit, and the damage that can be caused by a defective device can be very serious. So this chip was bought on mouser.com. It's an authorized dealer, and you can check the looks of the chip and find out yourself. So you see the pads here are copper. The color is copper, so that means that it was never used. And also the bottom side has absolutely no solder, and it's the same color. You see, it's kind of yellowish. It shines. So let's prepare this chip for soldering and solder it on the motherboard. So let's begin placing the components back. Also, I want to clear this area too, here. Be safe. Let's do this one. Coil here. Okay, let's move now to this area. Let's put some flux here, here as well. Anything that looks suspicious will be removed. Let's go. Okay, let's put some flux here to restore those pads and see if anything else is wrong here. I probably will also change those two. I don't like them. If you see, there is something red here on those contacts, so they might break like on the other chip. So better let's remove those two and replace them. It's not hard to do. But now use some solder to fix the pads. Well, so it seems that just soldering here will not solve the issue, because we have some pads that are broken. If you compare the lengths of these pads to this pad, you see those are cut in half from the corrosion. So they probably do not make the appropriate contact. To see this, we'll clean a little bit this area to reveal the traces, and then we will connect any missing pads with the traces. Let's clean well, and you can see here that, let's go a bit closer, these black boards are not very helpful when you want to trace something out, but we'll find where those traces are going. So here we have two traces. One trace is here. Let's expose that trace. The other one is here. And we have from the bottom side also here and here. Which seem to be okay, but we will have to check them just in case. I don't see anything coming to this one. Maybe it's not connected. But we can check on the other board to see if anything is missing. Okay, let's clean this area again. So those traces definitely go to those pads, but it seems that this one has nothing. It's a not connected pad. Also this one and this one. I'm not 100% sure, but we will check this on the other board as well. Now we will have to fix those pads. Let's do it. And then let's use some wire. Okay, let's clean. Now, before doing anything else, let's remove the chip from the other board and look for missing pads. If there is anything else that needs to be repaired, like those two traces, we will find out. This is the other motherboard that is fine with those pads here and traces. Let's look carefully so we don't miss anything. It seems that the first pad is not connected. The second one is also not connected. There are no traces around it. The third and fourth, we repaired those. We connected this line and this line. The fifth and the sixth pad are also not connected here. So I think we are fine. The seventh pad is here going down there. It's a thick pad, so it means it's either a power pin or a ground pin. That's it. Now let's fix any pads here that require a bit of soldering, and then we'll move forward to put some soldering mask here, so those traces do not come off when we place the new chip. I don't like this pad here. It seems that it's a bit corroded here, so let's put a wire so we are sure for that the connection is good. Let's do that. So now let's apply the soldering mask, and then we'll let it cure a bit. Okay, a little bit here. Here. Okay. This area has cured. It's ready to accept the new chip. Let's move to this area. If you remember, there was a resistor here, and as you see, the pad is completely missing. So we need to know, was there a bridge connection going somewhere, or is just this pad here that goes somewhere? We will use the other board as well for this area to determine if there is a missing pad or not. I see a bias here that should be connected here, so there is a bridge. I think if you scrape here, yes, so it seems that this one goes here, but we will check it now on the other board to be 100% sure about this. This is the other board, and indeed this trace goes here to this bias, so we were correct. This connects here and then it continues there. Well, this trace was going to this bias, so we have to connect it with the resistor that goes here, and we will scrape this area a little bit like this, and then after cleaning we'll place the missing resistor. Okay, a little bit of flux as always. Let's place the components first, and then we will connect the missing pads. Okay, and here as well. Okay, and now we need to run a wire to connect this with this. Okay. Okay, that seems good. And that also seems fine. So you see what the water does. It eats the conductor that combined with electricity creates that issue, like you saw here. So this is probably a 19 volt line here. That's why it got corroded so much. Let's clean this area a bit, and then let's move down. Make them nice and shiny again. Okay, here. All right. So now we have our chip and those 4 components here, and we are done. Let's do this. This goes here. Okay, let's start the flow now and put the chips to their place. Okay. Now we need to check the legs on those contacts. If they touch the board and the pads, then everything is okay. If not, we will solder the individual pads that are not connected well. So let's check that. This is a little bit off, as well as this and this one. This is normal because those two pads are a bit higher, so the surrounding ones are not making contact. We will solder each one individually and everything will be okay. Okay, so that was it. Let's test the other ones as well. This must be fine because there is no obstruction like the damaged area. But to be sure, it's always better to test them. Okay, let's clean a little bit and then we'll test this board. As for this tape, I'll remove it and replace it. I've noticed this vias here. They don't seem very good. So let's make this one too. Okay. I think now we are fine. So let's clean this area and test it to see our results. Okay, I have placed the memory, the SSD, two heatsinks for the CPU and the GPU, HDMI cable for the display, and now let's plug in the power to test again. Okay, and let's push the power button, and as you see, now the consumption is much higher, is 1.5 amperes, which is very good, and it's jumping up and down. That means that the CPU is working and communicates with the memory and loads the firmware and all this stuff. So we expect an image on the screen. Let's wait for it. As you can see, there is some action going on here on the SSD, so that's a very good sign. Still no image. I think you cannot have an image with this board without having the internal LCD display connected, but it will show once the SSD loads the graphics drivers inside Windows, so we can just wait. The motherboard has booted and now there's an image. You can see here the model number. It's an MSI GS63VR 7RF, and everything seems to be working fine. Let's run a quick video stress test with Furmark. And as you can see, it's running. But it's getting quickly hot because this is not the heatsink that has to be here, so we close it and let the customer do the full test. So that was it. A long repair, but it eventually got fixed. Thank you for watching. Bye now.